Dear students, in previous lecture we discussed the properties of definite integrals. Today we are going to use these properties to solve the definite integrals. Now the first one is find the integral of find the definite integral minus 1 to 1 mod x with respect to x, that is dx. Now you know that mod x is always x if x belongs to 0 to 1, that is when it is positive, and mod x is negative if x belongs to minus 1 to 0. So this means that by using property integral a to b f dx is integral a to c plus integral c to b fx, where c is point within this interval ab. We can write this as integral minus 1 to 1 mod x dx is integral minus 1 to 0 mod x plus integral 0 to 1 mod x, because 0 belongs to this. Now in interval minus 1 to 0, this mod x is always minus x, which implies that when x belongs to minus 1 to 0, we can write this mod x as minus x. And in interval 0 to 1, it is positive, which implies that mod x is simply x. Now we can differentiate this integral minus 1 to 0 x dx, which is minus x square upon 2 from interval or from minus 1 to 0, and for this 0 to 1 integral x dx, it is x square upon 2 0 to 1. Now we will substitute these values, which is minus times 0 square upon 2 minus minus 1 square upon 2 plus 1 square upon 2 minus 0 square upon 2, because integral a to b fx dx is f of b minus f of a, where f is antiderivative, or where f is integration of this given f, which is simply minus into minus 1 by 2 plus 1 by 2, that is simply 1 by 2 plus 1 by 2, which is 1. So in this way we can solve this integral by using the property of definite integral. Now similarly, if we have another function which is of modulus function from interval 0 to 4 mod x minus 1 dx. Since mod x minus 1 is x minus 1, that is positive if x minus 1 is greater than 0, which implies that x is greater than 1. So this means that when x is greater than 1, this mod of x minus 1 is x minus 1. Similarly, this mod x minus 1 is minus times x minus 1 if x minus 1 is less than 0, because by definition of modulus function, which is simply when x is less than 1. So this means that when x is greater than 1, this mod x minus 1 is x minus 1, and when x is less than 1, this mod x minus 1 is minus times mod x minus 1. So using property which we use in this integral, first integral, we can write this as 0 to 4 mod x minus 1 is 0 to 1 mod x minus 1 plus 1 to 4 mod x minus 1 dx. Now in interval 0 to 1, because x is less than 1, this mod x minus 1 is minus x minus 1, while as in this interval 1 4, this mod x minus 1 is always x minus 1. Now integrating this, it is minus x, that is minus x square by 2 plus 1, its integration is x from interval 0 from 0 to 1, and x, its integration is x square by 2, while as minus x is minus 1 is simply minus x from 1 to 4. Now substituting these values by the definition of definite integral, we simply get 5 after simplifying this. So this is the definite integral, required value of this definite integral. So from this we conclude that if we have the modulus function, we have to check the points, or we have to simply check the part of domain where the function is positive and where the function is negative. Then we have to break the given integral, like here interval was 0 to 4, and we break it from 0 to 1 to 1 to 4. Similarly, in each and every modulus function, if we have to solve the definite integral of that modulus function, we have to find those parts of, or simply we have to break the domain into two parts and find the part in which this function is negative and the function is positive. So in this way you can solve any modulus function, any definite integral of the modulus function. Now here, find the value of this integral 0 to pi by 2 log sine x dx. Now this is the standard integral which we will use in the later. Let I equals to 0 to pi by 2 log sine x dx, name it equation first. We know that 0 to a f x dx is 0 to a f of a minus x. Now here a is pi by 2, so we can use this property, that is I equals to 0 to pi by 2 log sine pi by 2 minus x dx. Now sine pi by 2 minus x is cos x, which implies that it is I is 0 to pi by 2 log cos x dx. Now name it equation second. Now adding these two equations, on LHS we have I and I, which is 2i, and on RHS we have integral log sine x plus integral log cos x, that is integral 0 to pi by 2 log sine x plus log cos x dx. Now log a plus log b is log ab, which implies that it is simply log sine x into cos x. We know that twice sine x cos x is sine 2x, which implies that multiplying and dividing to this sine x and cos x, we simply get 2i equals to 0 to pi by 2 log sine 2x upon 2, because sine 2x is twice sine x cos x, and 2 will cancel, so we simply get sine x and cos x. Now using log m by n, which is log m minus log n, that is log sine 2x minus log 2, which is 0 to pi by 2 log sine 2x minus 0 to pi by 2 log 2 dx, which is simply log 0 to pi by 2 log sine 2x. Now this log 2x is constant, so it comes out, so we simply get minus log 2 integral 0 to pi by 2 dx, which is simply x, that is 2i is equal to 0 to pi by 2 log sine 2x dx minus pi by 2, because using these limits it is pi by 2 minus 0, that is simply pi by 2 log 2. Now in this integral put t equals to, now we will here use the substitution method, put 2x equals to t, which implies that 2 dx is dt, which implies that dx is dt by 2. Now when x is 0, because limit is 0 and pi by 2, which implies that when x is 0, t is 2, t is 0. When x is pi by 2, t is pi. So this means that 2i becomes, in the given equation, 2i becomes 1 by 2, 0 to pi log sine t dt minus pi by 2 log 2, name it equation first. But we know that 0 to 2a f of x is 2 integral 0 to a f x dx if f of a minus x is f of x. Here pi can be written as 2 pi by 2, that means that this pi is actually 2a, where a is pi by 2. And log sine pi by 2 minus t is log sine t. So this means that f of a minus x is f of a, and using this property, that is 0 to 2a f x equals to twice integral 0 to a f x dx, because f of a minus x is f of x, which implies that 0 to pi log sine t dt is simply twice 0 to pi by 2 log sine x dx, because we break this pi as 2 pi by 2. Now which is simply 2i. Now this integral is 0 to pi log sine t dt is 0 to integral 0 to pi by 2 log sine x dx. Now using this in equation first, we simply get 2i equals to 2 by 2 integral 0 to pi by 2 log sine x. Now here this can be written as sine t can be written as sine x dx, because we can change the variables in definite integral, which is simply 2i equals to I minus pi by 2 log 2, because I is 0 to pi by 2 log sine x dx, which implies that I equals to minus pi by 2 log 2. Hence, integral 0 to pi by 2 log sin x is simply minus pi by 2 log 2 by using we solve this by using the properties of definite integral. So inshallah in tomorrow's video lecture we will discuss this exercise 7.11. So thank you.